So again, here is the summary of our transformations of parent functions. Given the real numbers a, b, c, and d, and the function f, the graph of y equals c times f of a times the quantity x minus b plus d is obtained from the graph of y equals f of x in the following steps. So again, when we are trying to identify the transformations of our function, we need to determine what each one of these constants a, b, c, and d is going to be, right? These constants are going to tell us our different transformations. The constant a, that's a constant multiple in front of the x inside of the parent function. That determines our horizontal scalings. Those are our horizontal stretches and horizontal shrinks. We also have a constant b, right? B is a constant that is being subtracted inside of the parent function. And notice that when identifying b, it is important that if we have a constant multiple other than 1 in front of that x, we need to factor that out from both of our x and our b terms. We'll go through a few examples of that coming up. All right, but identifying b will tell us our horizontal shifts. Those are our translations to the left and to the right. The constant c is a constant multiple, again, a constant connected by multiplication that comes in front of the parent function, c times f. That gives us our vertical scalings. Those are our vertical stretches and vertical shrinks. And finally, the constant d is a constant that is added on the outside of our parent function. The constant d on the outside of the parent function will tell us our vertical shift. That's our vertical translations up and down. Remember, if c is negative, then there is going to be a reflection in the x-axis. That is the constant multiple that comes in front of the parent function. If a is negative, that's the constant multiple inside of the parent function in front of the x, there is a reflection in the y-axis. So remember this general form and make sure you are taking the time to identify what each one of these constants is so you can get the proper transformation. When you guys go to make your sketch, complete your transformations in this order. Number 1, scale. Do your scalings first. Those are going to be your horizontal stretches, horizontal shrinks, vertical stretches, and vertical shrinks. After you scale the function, reflect it. Reflect your graph in the x-axis and or the y-axis. And finally, do your shifts last. Shift the graph vertically, shift the graph horizontally. Scale, reflect, and then shift. Let's go through some examples and see if we can't put this to use. Determine the parent function, describe the transformations from the parent function, and sketch the graph. So we have g of x is equal to the quantity x minus 3 squared plus 2. Make note of the general form. Well, the first thing we want to do in all of these problems is identify the parent function. Again, a parent function is just the most simple form of a particular type of function. And we need to identify or classify the type of function that we are dealing with. G of x is going to be a quadratic. Notice the squared power here. All right, that means our parent function is going to be f of x equals x squared. That is the most simple form of a quadratic function. So what's different in our function g compared to our function f? Well, right off the bat, notice that inside of the parent function, I am subtracting a 3. Inside of the parent function, I am subtracting a 3. That means that our constant b is equal to 3. The constant b controls our horizontal shifts, and because b is 3, that means our graph is going to shift to the right 3 units. Well, what else is different in our function g of x? We are also adding a 2 outside of the parent function. We are adding a 2 outside of the parent function. Adding a constant outside of the parent function controls our vertical shifts. In this case, d is equal to 2, which means our graph is going to shift up 2 units. Those are all of our transformations. Now we can begin our sketch. It's always helpful to start out with the sketch of our parent function. Here we have the graph f of x is equal to x squared. Well, we talked about the ordering, right? We want to scale, reflect, and then shift. Well, in this particular case, we don't have any scalings, we don't have any reflections, so we can just begin with our shifts. Every single point on our parent function is going to shift to the right 3 units and up 2 units. So all we need to do is translate all the points to the right 3 and up 2, giving us our function g of x. Here we have the graph g of x is equal to the quantity x minus 3 squared plus 2. Okay, let's try another one here. Determine the parent function, describe the transformations from the parent function, and sketch the graph. We have g of x is equal to the quantity negative x minus 2 cubed minus 1. Again, note the general form. So the reason I keep putting this general form up here is so that you guys begin to recognize whenever there is a constant multiple of a inside of the parent function, as well as some sort of horizontal translation occurring at the same time from a constant b, okay? It's really, really important that you factor out that constant multiple a from each one of those quantities. Notice that in the general form, it's a times the quantity x minus b here. Well, that means what we want to do is factor out a negative 1 from both of these terms inside of the parentheses. Now, that negative is still going to stay in the parentheses, but we're just going to factor it out from these two terms. This leaves us with g of x is equal to negative 1 times the quantity x plus 2, all of that in parentheses cubed. This will now allow us to get the proper transformations. So let's identify the parent function. What type of function are we dealing with? This is a cubic function, therefore our parent is f of x equals x cubed. What is different from the parent function? Well, number one, just like going from left to right, the first thing that we see is different is this constant multiple of a is something other than 1. In this case, the a is a negative 1. And when a is negative, that means we are going to have a reflection in the y-axis. Notice that that is a constant multiple that is located inside of the parent function. It's inside of this grouping being cubed. Next, we have an x plus 2 inside of that. So this is our constant b. Remember that we are subtracting a constant b inside of the parent function. In order to get a plus 2, that means that b has to be negative 2. B controls our horizontal shifts. Because b is negative, that is going to shift our graph to the left 2 units. And finally, we have this minus 1 on the outside of the parent function. That's going to be coming from adding our constant d. That means d must be negative 1. It's the only way to get subtraction from this addition here. D is equal to negative 1, which means we have a vertical shift down 1 unit. So we start off with our parent function. Here we have f of x is equal to x cubed. Again, scale first. We don't have any scalings. Reflect second. We're going to take this graph and we are going to reflect it over the y-axis. Okay, there's my y-axis. Boom, flip it right over that y-axis. And notice, all right, now the graph goes up to the left and down to the right. Okay, after we do our reflections, then we can begin to shift. Every single point on this graph is going to shift to the left 2 units and down 1 unit. And guys, when you are doing your sketches, I'm not asking them to be perfect, okay? As long as you have the general shape and you can label 2 points, minimum of 2 points, I think that's great, okay? I'm looking for the general shape, label 2 points. One of the convenient things about all of your quadratic functions, cubic functions, absolute value functions, and square root functions is that they all contain the point 0, 0. So it's really easy to translate that point to get an idea of where your new graph is going to be. So we're going to take all these, shift them to the left 2 and down 1 unit. to get our answer. G of x is equal to the quantity negative x minus 2 cubed minus 1. All right, another example here. Determine the parent function, describe the transformations from the parent function, and sketch the graph. So you might be noticing more and more things are starting to happen all at once, which is okay. Break it down and keep it simple. G of x is equal to negative 3 times the absolute value of negative 2x minus 8. Again, make note of the general form. So as we saw in the last problem, whenever we have a constant multiple a that's inside of our parent function, that's the constant multiple in front of the x, we want to make sure that we factor that out from any terms that are inside of that parent function. In other words, what do I need to do with this negative 2? I need to factor it out from both of these terms inside of this absolute value. This gives me negative 3 times the absolute value. Notice it still stays inside of the parent function. Negative 2 times the quantity of x plus 4. All I've done is factored out that constant multiple of a from each one of those terms, and now it's in the general form, which will allow me to evaluate my transformations, determine my transformations. So what type of function are we dealing with? Well, it's an absolute value function. F of x is equal to the absolute value of x. What is different here from our parent function? Well, right off the bat, notice we have this negative, right? The constant multiple c that is in front of the parent function is negative. If c is negative, that gives us a reflection in the x-axis. Now, also notice that the constant multiple a, that's the constant multiple inside of the parent function, is also negative. That is going to give us a reflection in the y-axis as well. So we have two different reflections occurring here. We have a reflection in the x-axis and a reflection in the y-axis. Now, coming back to this constant multiple a, all right, the absolute value of a is greater than 1. This means that it is going to be a vertical stretch. Okay, the way I like to think about it is the negative here is what is responsible for the reflection in the x-axis. The 3 is what is going to be stretching it. Okay, reflection in the x-axis, 3, it gives us our vertical stretch. Now, as we said, the negative inside of the constant multiple inside of the parent function gives us our reflection in the y-axis. This 2 is going to give us a horizontal shrink. It's a horizontal shrink by a factor of 2. And finally, notice that we are adding 4 inside of our parent function. All right, adding 4. Well, what's our constant b? Remember, this is the form x minus b. That means b must be equal to negative 4 in order to get a plus 4. If b is negative 4, that means our graph is going to shift to the left 4 units. Let's do our sketch. So we start off with the shape of the parent function. F of x is equal to the absolute value of x. First thing we want to do is we want to scale. Well, we have two different scalings going on, all right? First one, let's look at our vertical scaling. We have a vertical stretch. The vertical stretch is by a factor of 3. All of our y's, all of the y values on this graph are going to get multiplied by 3. So in other words, this y value that was at y equals 1 is going to come to y equals 3. This y value that was at y equals 2 is going to get bumped up to y equals 6. This one that was at y equals 3 will get bumped up to y equals 9. Same thing on the other side of our absolute value function. Okay, notice that this point here at 0, 0 doesn't move because the y value 0 times 3 still gives us 0. Okay, so there is our vertical stretch. Now we have to apply a horizontal shrink. We have a horizontal shrink by a factor of 2. That means all the x-coordinates of all of our points are going to get divided by 2. In other words, this x-coordinate that was here at x equals 1 is going to move to x equals 1/2. This x-coordinate here at -1 will move to x equals -1/2. This x-coordinate that was at 2 will get bumped into 1. The one that was at -2 will get bumped into -1. Again, we take all the x-coordinates on our graph and we divide them by 2. That gives us our horizontal shrink. And finally, again, we want to now, we did our scalings, not finally. Now we need to do our reflections, all right? We reflect in the x-axis and the y-axis. It doesn't matter what order we do those in. Notice that reflecting it in the y-axis, well, that actually doesn't change our shape at all. We still have the same graph. But when we reflect this over the x-axis, that's our new image. Okay, we took that graph, we reflected it over the x-axis and the y-axis. And finally, now we can do our shifts. Again, scale, reflect, and then shift. Every single point now is going to be moved to the left 4 units. Moving to the left 4 units brings us to our final graph. G of x is equal to -3 times the absolute value of -2x minus 8.